everyone, welcome to Genius Squad YouTube channel. Here is another question, although this question was given as an assignment in your slide, but do you really understand how it was solved? And it even came out in your first test, Physics 103. Most of you chose the answer that was in the slide. Well, you were right, but do you really understand how it was solved? Follow me. The question says, water flows at the rate of what? 0.130 kilogram per minute. 0.130 kilogram per minute in a tube, and it is heated by heater given what? 27.2 watts. The inflow and outflow of water temperature are 27 and 17 degrees Celsius respectively. When the rate flow is increased to what? 40.75 watts, the inflow and outflow temperature remain unchanged. Calculate the specific heat capacity of the flow, that is, you are expected to calculate C, and you are the rate loss of the heat of flow. We're asked to calculate two things here. But if you want to calculate two things, one thing is very important to understand in this question is this power. This power, what is the function of this power itself? The function of power is that what? Imagine you are eating something. Automatically there will be heat loss and there will also be heat. That's the function of this power, right? You all know that for anything dissipating a specific power, there will be a specific heat given, released into that particular system, and there will also be a specific heat released outside the system. That particular heat that is released outside the system is what? Is the heat loss. Am I communicating? So to solve this particular question now, we have two cases. The first case is when our power is what? 27.2 watts, and the other case is when our power is what? 40.75 watts. I also have to understand something. They said the inflow and outflow temperature remain unchanged. Basically, the inflow and outflow temperature for the first watt will be equal to that of the second watt. Are you getting me? So we have to analyze this particular question into two cases, case 1 and case 2. Let's go. Follow me. So let's try to solve the questions. So the question says, for case 1, we have power is equals to what? Power is equals to what? MC delta theta plus what? Plus HL, because it is this power that is performing two things. Power is given it, and at the same time is losing it, right? So, but we were given a specific mass in the first case. The mass that we were given is in what? Is in 0.120 what? Kilogram per watt per minute. But is this the standard unit of mass? No, it has to be converted. Am I communicating? So we have to convert this particular thing. So for us to get our actual mass, that will be 0.120 over what? Over 60. Am I communicating? Then we get what? Let me punch my calculator. So by the time I do what? 0.120 divided by what? Divided by 60, then I'm going to get what? I'm going to get 0.002 kilogram. I've already converted my power, right? So now understand me that what the first power is what? Is 22.4. Am I communicating? And I'm looking for my C. And I'm already told that what the inflow and outflow temperature remain unchanged for the both cases, right? And I'm looking for my L. So let me just input what? Input my values. Therefore, the case 1, I have what? 22.4 to be equals to what? MC. The M I've already converted. That will be 0.002 kg times what? Times C times what? Change in temperature. Please take note. The change in temperature remains the same. Do you understand? That is 50 minus what? Minus 17. Am I communicating? So that will be 17 minus 15. The temperature given. That's about what? That's about 2. I don't know the exact temperature, but let me just use 2 because I've already rubbed the question up. Let me just use 2, right? Plus what? Plus HL. Am I communicating? Plus what? Plus HL. This is my first one. This is equation 1. This is equation what? Equation 1. Then to the second what? Then to the second cases. The second case now what? Then let's say the power has already changed to about what? 40.7 watts. I can't really remember the parameters. Am I communicating? But then I still give you the mass in form of what? Maybe 0.160 kilogram per watt, kilogram minute again. Then you still have to convert. So you do 0.160 kilogram minutes over what? Over, then that will be 60, right? Then you do your conversion. So that will be what? 0.160 divided by what? Divided by 60. So then I'm going to get what? I'm going to get, so that will be 0. What? 0.00226 kilogram, right? So I'm going to get what? Okay, so that will be for my case, for my second case. So I'm going to get 0.0026 kilogram, right? Times C, you know the temperature changes is still the same thing, right? So that will be times 2 plus what? Plus HL. Am I communicating? So at the end of the day, we have two equations. This is what? Equation 1, equation 2, right? This is equation 1 and this is equation 2. And this one is already turned to something else. So we have to what? Subtract equation 1 from equation 2. Hope you are following me. So let's go. So when I subtract equation 1 from equation 2, then I have what? I have 40.7 watts minus what? Minus 22.4 will now be equals to what? Will now be equals to 0.002 k 0.002 c. Sorry, yeah, we are subtracting 2 from 1, so that will be 0.0026 minus what? Minus 0.0022 c, then is equals to what? So that will be what? We have to multiply them by 2. Sorry, we have to multiply the exact temperature by 2. Apologies. So when you do 0.2, when you do 0.002 times 2, then you get what? Then you get 0.004 kg, right? 0.04 c, you know, the c is already there. Then this one as well, for the second case, we do 0.026 times what? Times 2, then you have what? Then you have that's 0.0052 c, right? So this is for my what? For my equation 1. This is for my equation 1, this is for my equation 2. So we now be equals to what? So by the time I want to subtract, that will now, it will now be equals to this one minus this one, right? The reason why I have C is what? Is the C that I'm looking for. Am I communicating? So I'm going to do what? 0.0052 minus what? Minus 0.004. So that will be equals to what? That will be equals to, so at the end of the day, I'm going to get what? 0.0012 C. Remember, we are subtracting this one from this one. Automatically, this one will have what? Will have cancelled out, right? So, and my HL has already what? It has already cancelled out. So then, I'm not going to do what? So that will be my 40.7 minus 22.4. That will be equals to what? That will 18.3 will now be equals to 0.0012 c. Then my c will now be equals to what? 18.3 divided by what? 0.0012. So then 18.3, that's 18.3 divided by 0.0012. So then I'm going to have what? I'm going to have 15250 as my what? As my unit, as my value of my what? Of my specific heat capacity. Do you understand? So that is just how you can definitely calculate. So since you already calculated your what? Your C, then how will you now calculate your heat loss? Because this is your heat loss. You will now substitute this value of your C into any of your equation. Either you use equation 1 or what? For equation 2. Please don't forget your unit. Always what? Attach your what? Your unit. Do you understand? So me using what? Me using equation 1. So I'm going to use equation 1 since, although this is not what was gotten in your slide, but I've already changed my values. Take note. This question I'm solving is different from the one in your slide. I've already changed what? I've already changed values. Am I coming? So I'm going to just go to equation 1. So I'm going to do 22.4 is equal to 0.00 what? 0.002 times what? Times what of the C that I've gotten? 1520. Am I communicating? So that will now be equal to what? Times 1520. So that will be what? Times 2 plus what? Plus HL. Am I communicating? So after I've already gotten it like times 2 like this, then I'll now say 22.4 is equal to what? Multiply all this together. So that will be what? 0.0002 times 1520 times 2. So that will be equals to what? So that will be equals to 6 point what? 6.08 plus what? Plus HL. Am I communicating? So at the end you do your normal mathematics, then your HL will be equals to what? 22.4 minus what? Minus 6.08. Am I communicating? So my HL will be equals to what? 22.4. 22.4 minus what? Minus 6.08. Minus 6.08. So that will now be equals to what? 16.32. Do you understand? So in any question that you are solving, make sure that you are solving to the extent that you are changing values yourself. Do you understand? That is the University of Adosai. They might give question from the examples, they will just try to change values. So thank you very much, and I believe you understand. So if you have any question, you can reach me out on the comment section, and don't forget to like, share, and what and subscribe. Thank you very much.